Imagine looking at the universe like a vast, sprawling masterpiece painted across the canvas of the cosmos. But what if, in the middle of this seemingly perfect work, you found a smudge, a cold, empty void that shouldn't exist? This is the cold spot, a mysterious region in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Scientists have debated its origin for decades. Is it the remnant of a massive cosmic event, a statistical anomaly, or something even stranger? What if this cold spot isn't a flaw in the fabric of the universe, but a glitch, an artifact of a simulated reality? Could this void be the cosmic equivalent of a rendering error in a computer program? And if so, what does that tell us about the nature of our existence? In this video, we'll uncover the mystery of the cold spot and explore the tantalizing possibility that it might be proof we live in a simulation. Ready to venture into the unknown? Let's dive in. The cold spot, first identified in 2004 by the Wilkinson Microwave Anisotropy Probe, is a puzzling anomaly in the cosmic microwave background, the faint radiation left over from the Big Bang. Located about 1.8 billion light-years away, this region is colder than the surrounding universe by about 70 microkelvins. While that might not sound significant, on a cosmic scale, it's like finding a drop of ice in a perfectly heated pool. At first glance, the cold spot seems like an unusual but natural phenomenon. Scientists propose theories like the supervoid hypothesis, suggesting it could be a vast region of space with fewer galaxies, leading to less gravitational influence and cooler radiation. Others believed it might result from quantum fluctuations during the early universe. But none of these theories fully explain the cold spot's existence. Its sheer size, spanning hundreds of millions of light-years, defies conventional astrophysical models. This unresolved mystery has led some researchers to propose more radical explanations, including the idea that it might be evidence of a simulated universe. Why? In a simulated reality, such anomalies could result from computational shortcuts or rendering errors. The cold spot could be a cosmic glitch, much like how digital simulations sometimes create visual artifacts when processing complex environments. In an era where simulation theory gains traction, championed by thinkers like Nick Bostrom, phenomena like the cold spot demand a closer look. Could it be a subtle clue left by the architects of our reality? Or does it point to a deeper truth about the universe's structure? Stick around as we delve into the challenges this anomaly presents and why the simulation theory might hold the answers. The cold spot is more than a scientific curiosity. It's a challenge to our understanding of the universe. One major issue is the scale of the anomaly. The cold spot spans roughly 1.8 billion light-years, making it one of the largest known structures in the universe. If it's a supervoid, it's unlike anything we've seen before, as even vast cosmic voids don't typically create such pronounced temperature differences in the cosmic microwave background. Another challenge lies in the lack of a comprehensive explanation. Most astrophysical models rely on the idea that the universe is relatively uniform at large scales, a concept known as cosmological homogeneity. Yet the cold spot stands as a glaring exception. If it's natural, it forces us to reconsider foundational theories about the universe's formation and structure. Then there's the statistical anomaly. Some researchers argue that the cold spot could simply be a rare fluctuation, a 1 in 1,000 chance. But even this explanation feels unsatisfying. Why here? Why now? And why does the anomaly align so closely with our detection methods? This is where the simulation hypothesis comes in. In a simulated universe, anomalies like the cold spot might not need to follow natural laws. They could be artifacts of a system designed to simulate a vast, complex cosmos without rendering every detail perfectly. But if that's the case, what kind of simulation are we in? And why would the creators allow such an obvious clue to exist? Could the cold spot be a deliberate marker, a breadcrumb leading us to question the nature of reality itself? The mystery deepens as we explore the potential explanations, including the tantalizing idea that the cold spot is a glitch in the simulation we call home. To understand how the cold spot might connect to simulation theory, we need to examine the mechanics of simulated realities. In a simulation, computational efficiency is key. Rendering every detail of a universe down to its smallest particles would be computationally impossible. Instead, simulations might use approximations and shortcuts, rendering only what's necessary to maintain the illusion of continuity. Anomalies like the cold spot could arise when the simulation prioritizes efficiency over precision. This idea aligns with observable phenomena in physics. For instance, quantum mechanics often reveals strange, counterintuitive behaviors at small scales, leading some to speculate that our universe might operate on pre-programmed rules rather than infinite complexity. Could the cold spot be evidence of a similar shortcut at cosmic scales? Some scientists and philosophers suggest that simulated universes might be designed to mimic natural processes, but could occasionally reveal signature glitches. The cold spot, with its inexplicable properties, fits this profile. Unlike other cosmic voids, it stands out as an almost deliberate aberration, as if placed there to catch our attention. Moreover, the cold spot's location in the cosmic microwave background, the backdrop of the universe, makes it particularly intriguing. If you were designing a simulation, the cosmic microwave background might serve as a static background texture, simplifying the simulation's computational demands. A glitch in this texture, like the cold spot, could hint at the underlying artificiality of the universe. But why would the architects of a simulation allow such an error to persist? Perhaps it's not an error at all. It could be a message, a signal meant to provoke thought and curiosity. Or it could be a test, challenging us to recognize the simulation we inhabit. As we explore these possibilities, the cold spot transforms from a scientific anomaly into a philosophical enigma, a potential clue to the very nature of existence. Here's the big reveal. Recent studies have deepened the mystery of the cold spot, pushing simulation theory closer to plausibility. In 2015, researchers at the University of Durham proposed that the cold spot might be linked to a massive cosmic collision, a bruise left by our universe colliding with another in a multiverse scenario. This explanation is fascinating but raises even more questions. If we're part of a multiverse, could each universe be a separate simulation and the cold spot a boundary artifact? Another breakthrough came from computational simulations of the universe. Scientists attempting to model the cosmic microwave background have found it incredibly challenging to replicate anomalies like the cold spot. This suggests that the anomaly isn't just a statistical outlier. It's something fundamentally unique. The most compelling argument for the simulation theory, however, is its explanatory power. While natural theories struggle to account for the cold spot's properties, the simulation hypothesis frames it as an inevitable result of computational limitations. If the cold spot is a glitch, it provides direct evidence that our universe operates on discrete, programmable rules. This realization reframes the cold spot not as a problem, but as a solution, a key to understanding the artificial nature of our reality. If true, it means we're not just observing the universe, we're uncovering its code. But what does that code mean? And what does it tell us about the creators of our simulation? The cold spot is more than a curiosity. It's a puzzle that challenges our understanding of the cosmos. From its discovery in the cosmic microwave background to the unresolved debates about its origins, this anomaly stands as a reminder of how much we still don't know. We've explored its possible explanations, from natural phenomena like supervoids to radical ideas like multiverse collisions. But none of these theories fully account for the cold spot's strange properties. Instead, simulation theory offers a compelling framework: the cold spot as a computational glitch, a visible clue in the fabric of a simulated universe. This idea forces us to confront profound questions. If we live in a simulation, what's the purpose of the cold spot? Is it a flaw, a test, or a deliberate message from the simulation's creators? And what does this mean for humanity's role in a potentially artificial cosmos? As technology advances and our ability to probe the universe deepens, we may uncover more anomalies like the cold spot. Each could bring us closer to understanding the nature of reality, or to realizing we're part of something far greater than we imagine. For now, the cold spot remains a tantalizing mystery. But in that mystery lies the potential for discovery, not just about the universe, but about ourselves. What do you think about the cold spot? Could it really be evidence of a simulated universe? Or is there a natural explanation we've yet to uncover? Share your thoughts in the comments below. We want to hear your theories. And if you're fascinated by simulation theory, check out our other videos exploring cosmic mysteries and the nature of reality. Don't forget to like, subscribe, and hit the bell icon to join us on this journey into the unknown. Thank you for watching.